there, Math Analyzers. Welcome to your Chapter 7 Lesson 1 video. But before I get started on Lesson 1, let's do an overview of what we're going to see in Chapter 7, which is logarithms and exponents. So, the basics of what you need to know is that logs are exponents and exponents can be written as logs. So, since that is the case, we need to start out with some exponents review. I'm going to do basic simplifying of exponents to start. Then I'm going to do graphing exponential functions, and I'm going to work into solving exponential equations. There are 2 days of homework when I do that video. I'm actually just going to do the pieces of the second day that are just kind of extended practice. So practice and continuing where we were. Okay. Then, of course, we'll do a quick review. There'll be a video for it, and quiz number 1. There are 2 quizzes. This is a lengthy chapter, just like chapter 6 was. Then we're looking at intro to logs, change of base formula, and properties of logs, which will be the basic foundation of using logarithms to represent your exponents. Okay? And then we'll review even starting back to solving the exponential equations before our chapter 7 quiz. Then the big ones where we really wanted to get to are solving logarithmic equations and solving exponential equations using logs. Okay, so the difference between these two will be very subtle, and I will show you what it is. And then, of course, we will graph logarithmic functions. Spoiler alert, they're the inverse of exponential functions. That goes back to chapter 2. And then we review and test. Okay, let's start with some basic exponents review. So here we go. Other way. There it is. All right. An exponent is when you take a base and multiply it by itself the number of times indicated in this nice little script up here. It's not a subscript, it's a upscript, an exponent. The answer to it is also known as a product because, oh, look, it's from multiplication of your base. Okay? So, what I'm going to just kind of review with you so that we can get back to the negative exponents are the powers of 10. Okay? And I'm going to start with 10 to the first power. Well, it'll probably remind you that anything to the first power is itself. Now, 10 squared is 10 times 10, right? Which is 100. 10 cubed is 10 times 10 times 10, which turns out to be 1,000. You might be picking up on something when it comes to my zeros and my exponent present. 10 to the fourth power is 10 times 10 times 10, which is 10,000. How many zeros? What was my exponent? Oh, fancy. So what's 10 to the 10th? How many zeros should I put behind my 1? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Woo! All right. Thousands, millions, billions, trillions, 10 trillion. 10 trillion. Whew. There you have it. Well, this will help me when I go backwards into the negatives because the whole idea here was how many zeros I have is based on my exponent, right? So I was raising to the first power, I had 1 0. I was raising to the second power, I had 2 zeros behind my 1. So what's 10 to the 0 power? How many zeros should I have behind my 1? 0 zeros. 10 to the 0 power is 1. Anything to the 0 power is 1. And it's based off of this. Now, think about it this way. Now think about 10 to the negative 1. Well, what that does is it moves my 1 back behind the decimal place 1 place. 10 to the negative 2 moves my 1 back behind the decimal place 2 places. 10 to the negative 3 moves the 1 back behind the decimal 3 places. Now, let me just convert those into fractions for you, and then this part that I always talk about will make sense. If I convert this into a fraction, that's 1/10. If I convert this into a fraction, this is 1/100th. And if I convert this into a fraction, this is 1/1000th. The negative exponent flips my base upside down. And then I raise it to that power. So the negative part of the exponent pushes the base down to be the denominator, and then you raise it to your power. Okay? For any time you see a negative exponent, that's the case. All right? Now, when it comes to actually applying this, so I'll put these here, in something like 2 to the negative 3, right? I move my base down, and then I cube. 2 times 2 times 2 is 8. That's where I get 1/8 from. Okay? The whole thing is being raised to the negative 2 power. So 1 moves down, 2 moves up, and then I square them. Well, 1 squared is still 1. 2 squared is 4. And that's where I get this whole number as my answer here. Now, if you've got something like this, the whole fraction is being raised to the negative 4, flip the fraction first, then raise everything to the 4th power. That flip of the fraction is what takes care of the negative piece. So you get 3 times 3 times 3 times 3, that's 81 on top. 2 times 2 times 2 times 2, that's 16 on the bottom. There is where I get 81/16 as my answer. Okay. Last but certainly not least is what if you have a negative inside as your base? If you have a negative as your base, negative number as your base, and you have an even exponent, you're going to get a positive answer anyway because the negatives cancel each other out. But if you have a negative base with an odd exponent, you end up with an odd man, right? A negative in the answer. So here it is still a flip of the base, and then we're raising it to the 3rd power. Okay, so I did still do the flip of the base. Negative 3 times negative 3 is positive 9. Positive 9 times negative 3 is the negative 27 for the bottom here. So negative 1/27th would be my answer. So I just wanted to walk through those with you. I know that in Algebra 1 we talk about negative exponents, but that has a tendency to be difficult for people to remember. A negative exponent isn't what makes your answer negative, okay? Negative exponent doesn't make your answer negative automatically. It does flip your base upside down. Just a reminder, anything to the 0 power is 1, and I just referenced y when I went through my powers of 10. Anything to the 1st power is itself, and I just referenced y again when I was going through my powers of 10, right? So what we're going to do now is we're just going to go back through all of those things here, raising things to powers, right? So 9 cubed, 9 times 9 is 81, 81 times 3. Oh, I'm probably going to get it wrong, so why don't I just do it right here? 9 cubed. There we go. That's what I thought, but you know, if I say it and I'm wrong and then it's on video and oh, at least I know 15 squared is 225. And again, if you don't, well, you were supposed to memorize your perfect squares by now, people, so what the heck if you don't know that. There it is. Okay. 1 times 1 times 1 times 1 is still 1 on the top. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81 for the bottom. This is flip over because we got a negative 2. Now raise it to the 2nd power. Leave it as a fraction because it's just so much easier to understand where all that came from when you see it in fraction form. What's being raised to the 0 power here? So I know that anything to the 0 power is 1, but you need to be careful about what's being raised to the 0 power when you're asked to do that. The only thing being raised to the 0 power in part E is the x. The 4 is not. So this is really x to the 0 power is your 1, but you've got 4 times 1 here, which is 4, versus f, where the whole thing is being raised to the 0 power. So the whole thing is 1. So don't just jump to 1 is your answer if you see something raised to the 0 power. make sure it's either the whole thing or just one piece that turns into that 1. 8 to the negative 2, so move 8 down to the base and then square it. 8 times 8 is 64, so 1/64. 6 to the negative 3, so move 6 down in the base and cube it. That would be 1/216. And this flips fully, so the 2 comes up and the 1 goes down. But do I really have to worry about a 1? Not really, because 1 cubed is still 1. So 2 times 2 times 2 is 8. And there we are. Make sure you understand where I got all those from, because that's stuff that you need to make sure you understand first before we can do all the other pieces of exponentials throughout this unit. Speaking of, when we talked about radicals, I did tell you how a radical is a fractional exponent. That's where it is coming from. So when I am looking at these, when I raise x to the 1/2 power, I'm really taking a square root. When I raise x to a 1/3 power, I'm really taking its cube root. When I raise it to the 1/4 power, I'm really taking its 4th root. The conversion is m over n being your index on your radical, meaning what root number are you taking, and m being the exponent on your base in here. Okay, or the other way that sometimes you'll see this written is n is the index out here, x is in here, and the whole thing is being raised to the m power. It actually doesn't matter which order that happens, which is a really cool result of the exponents rules we've been looking at. Okay, so all this means is that we can convert radicals into fractional form and vice versa. We can convert a fractional exponent into radical form. Sometimes people prefer to see the radical, sometimes people prefer to see the exponent. In either case, you can go back and forth. And these are just convert, so all I'm going to do is convert here, okay? All I'm going to do is convert. 1/2 power is just taking a square root, okay? So, and that's because this is raised to the 1, right? And we don't have to write that. Notice my index here is 2, but I don't have to write it because a square root is so often the root that you're taking, you don't need to write an index of 2. It's just like if you have a 1x, you have x, right? You don't have to write that 1 in front of it because it's already there. You're already taking this root. So that doesn't need to be written. By simply having it, you're taking that square root. Now, same here, it's still square root that I'm taking here with this 13x, but you can either write it this way where the whole thing is being cubed after the fact, or you can write it as the 13x in here is being cubed. Because see, I'm bringing the whole thing up to the 3/2 power. Again, this is just conversion. And again, this is just conversion, okay? So 4th root, because that's my denominator, 3x squared y, the whole thing raised to the 3rd power, or the 4th root of 3x squared y, all raised to the 3rd power after the fact. Either of those works. Now what we're going to do is convert the radicals into fractional exponents. So a square root is a 1/2 power. Notice 14x isn't being raised to a power. So that means that's a 1 that's going to be your numerator. So 14x is being raised to the 1/3 power there. Okay, the whole thing is being raised to the 5th, so that's going to be our numerator. And the root outside, the index is 6. So this is going to be 17y raised to the 5/6 power. Just converting back and forth. I'm not asking you to evaluate anything. Here, I am asking you to evaluate it on exercise 4, right? Let's see here. I'm taking a cube of 8, and I'm taking the cube of x to the 7th. So 7/3 is my exponent, but notice there's nothing where that's in parentheses. So the 8 is actually taking the cube root of, and what times what times what gives you 8? 2. So Here we go. Choice 2. The line is over here, but that seems a little ridiculous, so I'm just going to put it right there. Okay. Now, these need to simplify into radicals, right? Or simplify the following radicals, right? But I don't want you to panic. This can easily convert because what's the exponential rule when you raise a power to a power? You multiply. 3 times 1 is 3, 2 times 2 is 4. So this is 16 to the 3/4 power. So that's the first simplification I'm going to do. Next thing I'm going to do is convert this into a radical. Okay, so let's convert this into a radical. This is the 4th root of 16 cubed. Okay, well, let's see. What's 16 cubed, right? And we got this graphing calculator, use it. 16 cubed is 4,096. Let's take the math, and there we go. The 4th root of our answer, second, and negative gives me our answer from above. So I could type 4,096, or I can do that, and that types 4,096 for me, and there you go. So look, I just did that on my own. Now there's another way you can do that, so I'm going to show you that the answer here is 8, and I'm going to show you the other way, which is if you took the 4th root of 16 and then cubed it, you'll also get 8. And let me just prove that to you. So take the 4th root of 16, and we get 2, because 2 times 2 times 2 times 2 is 16. And now take 2 and cube it. There you go. So either way, notice, either way, we simplify that. Same kind of thing here, right? So you can take the square root of 4 and then cube it. What's the square root of 4? 2. 2 cubed, 8. Or you can cube 4 and take its square root. Okay, so there's another way you can do it. 4 cubed is 64. And what's the square root of 64? 8. So all I'm saying is don't panic. Do the conversion and use the graphing calculator if ever you're asked this. This is really just show and tell for me. I'm not really going to be testing you on this part. I really want to get into logs with you. Okay, we're taking the 4th root of all these fun things. Well, we already know the 4th root of 16 is 2 because we just did that. But how do you do it with an exponent on a variable? You divide. Remember, when it was just a square root, you just divided by 2 to get the final exponent answer. That's still the case. You just divide by the index out here. So 16 divided by 4 is 4. There you go. That's it. That's how we do those. Just as a quick review, there are our properties of exponents that I've just kind of gone over, and notice that those are the same as these properties as applied to radicals, because radicals are exponents. That's why whenever you use PEMDAS, the E also includes any square roots. Okay, so any roots that would be taken there. Well, I hope you've enjoyed this little exponents review. Just use the examples I did to do your homework. I believe some of them are the same or just converting, like what I was looking at. So just make sure you're reading before you panic. But if you need any help, turns out I know what I'm doing. I can help you with it. Okay? Good luck, guys. I'll be seeing you soon. Bye.